FRQ topic 3, rate in, rate out. Here are the recent years that it has been seen, and this is using the fundamental theorem of calculus. This topic exclusively uses the fundamental theorem of calculus. So, rate in and rate out. You will be given a rate, okay? You might be given two rates, okay? You might be given only the rate in or only the rate out or both, okay? The integral of a rate. The integral of a rate is an amount. So, the integral of a rate in is the amount in. The integral of a rate out is the amount out. If you can know that, these questions get very, very easy. And the amount in is the integral of the rate in. The amount out is the integral of the rate out. It seems so easy. Okay. You will also likely be given an initial amount, okay? And that has to be taken into consideration if you're asked for an amount that's left at the end of some time period, okay? If I gave you $50, how much money would you have in total? In total. Well, it depends on how much you started with, right? Yeah? If you started with $100, then you will then have $150, right? If I gave you $50, it doesn't mean you always will only have $50, right? So, anyway, I say that because you'd be surprised how many people just don't use this initial amount. That's important. Your ending amount is your initial amount plus the amount that came in minus the amount that went out. Yeah? It just makes sense. Yeah? Okay. So, in integral form, the ending amount is the initial amount plus the integral of the rate in minus the integral of the rate out. Okay. Don't forget about the candidates test. Sometimes you need that. Like when they say what was the maximum amount present or the minimum amount present during a situation. Okay. And then you might be asked about increasing or decreasing amounts or rates. Okay. All right. Okay, let's take a look at a problem. We're going to take a look first at the problem from 2013. Okay, this is before I taught this course, but I know that the global average was 3.9. On a certain workday, the rate in, let me get a pen here, the rate in tons per hour at which unprocessed gravel arrives. The rate it arrives at a gravel processing plant is modeled by this function. That's the rate in. By the way, these are oftentimes, almost always with a calculator. Okay, so I'm going to get my calculator out. Hopefully it has some charge in it. It does. Yay! Clear out everything that's there. All right, I got my calculator ready. That's going to go in for my Y1. All right, so I'm going to put my rate in for Y1. 90. So everybody do this. I double check, make sure I put it in there right, because all of my answers are going to deal with this value. So I think it's right. I'm in radian mode, of course. Okay. All right, and then they give me a window. That's nice. Okay, at the beginning of the workday, the plant has 500 tons of unprocessed gravel. That is our initial amount. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. Oh, okay, so we have a rate in of unprocessed gravel, and then it's being processed, so the rate out will be 100. The rate out is 100. Normally I put the rate out in for my Y2, but since it's just 100, I may not need to do that, since it's just a constant. Okay. All right, part A. Find G prime of 5. Well, they gave me G. I want G prime. I have a calculator. G is stored in for my Y1. G prime of 5, not a problem. Derivative of Y1 at 5. Not a problem. Negative 24.587. Remember, at least 3 values after the decimal point. Okay? Using correct units, interpret your answer in the context of the problem. Okay, so I'm interpreting G prime of 5. G is a rate. G's units are tons per hour. So what would G prime be? Well, G prime's units would be tons per hour per hour. It's the rate of the rate. It's the rate that G is changing. So I'm going to say what it is. So I like to begin with my time. So at 5 hours, the meaning of the 5. At 5 hours, the rate. Now I am describing G here, and they told me what G is. G is the rate that unprocessed gravel arrives. The rate that unprocessed gravel arrives at the plant. Oops, at the plant. That's just G. Now I want G prime, so the rate that unprocessed gravel arrives at the plant is changing at the rate of G prime of 5. Now I need units on G prime of 5. What were our units? Tons per hour per hour. Or you could say tons per hour squared. Okay, so that's what I would write for my answer, but just for your sake. The rate that gravel arrives at the plant. This is just what G is changing at the rate of. That's what you do for every prime. Your function is changing at the rate of. That's what you do. Okay? Part B. Find the total amount of unprocessed gravel that arrives, the amount that arrives at the plant during the hours of operation, 0 to 8. So the integral of the rate in gives you the amount in. The integral of your rate in gives you your amount in. So Math 9, Y1, there's our answer. I'm looking at the directions to see if they told me to round. They did not tell me to round, so I'm going to keep all of my values there. At least 3 places after the decimal point. I like to give 4. It makes it easier for me to grade your work to see if you rounded that last place or not. Okay, that was that for that one. Part C now. Is the amount of unprocessed gravel at the plant increasing or decreasing at time 5 hours? okay, is the amount increasing or decreasing at time 5 hours? Well, it depends on the rate in at 5 and the rate out at 5. Is the rate in bigger or less than the rate out at 5? Right? So the rate in at 5 and the rate out at 5 I know is 100. What is G of 5? G of 5 is the rate at 5, the rate in at 5. Okay? It's 98.140. The rate out is 100. So is the amount of unprocessed increasing or decreasing? It's decreasing. G of 5 is less than 100. It's 98.140. I don't have to say the value that it is, but I know that that's what it is. Therefore, the amount of unprocessed gravel is decreasing at time 5. Excuse me. Still working through this little summer cold. Alrighty. Part D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on the workday? 0 to 8. Maximum amount. Candidates test. It's an absolute max. So I'm going to use the candidates test. Okay. My independent variable is T for time. I am finding the amount of gravel. The amount of gravel. I think I'm going to call that A of T. All right, the amount of gravel. And I know that the amount is equal to the initial amount was 500. They gave me that in the problem. Remember the initial amount plus the integral of the rate in. I'm going to start at 0 and go to T of the rate in minus the amount out, the integral of the amount out, okay, of the integral of the rate out, sorry. Okay, so that's the amount. So 0 to 8, and then I want the critical numbers. That's when A prime is 0. Well, A prime is, what's the derivative of 500? 0. What's the derivative of this integral? G of T. What's the derivative of this integral? What's the derivative of that integral? The derivative of T is 1. Put T in for T, but there's no T, so it's just minus 100. Okay? That is equal to 0. And changes. I want the maximum. From positive to negative, because it's an absolute max. I want the absolute max, so I want it to change from positive to negative. At T equals, okay, to my calculator I go. And for y1, I'm going to turn off the graph of y1 and y2, and then I'm going to say y1 minus y2. I want to know where this changes from positive to negative from the intervals on the interval 0 to 8. Right there. Clearly I needed some more y values. I'm going to make this like negative, maybe, I don't know, 100 to 100. And then I'm also going to add in a 0 here so I can find out this value. There we go. That was better. Okay, so second calc 5, enter, enter, enter. I got I can hardly read this, 4.9234. I'm going to quit. I'm going to take that x value and store it in for A. I'm going to say that I did that. I don't want to call it A though, because A already means amount here, so I'm going to call it B. Okay? And then I can just put B here. Okay. What is the amount at time 0? They gave me that answer. That was 8. What is the amount at time 8? Well, for the amount at time 8, it's 500 plus the integral 0 to 8 of g of t minus the integral 0 to 8 of 100 dt (500) plus 0 to 8 of y1 minus 0 to 8 of 100, which is 800. I already know that. This is going to be 525.551. 525.551. And now I need to do the same thing for that B value. And I really do not have to rewrite this because I wrote this right here. Since I wrote this right here, I'm telling how I got all of these values. So I really don't have to rewrite these two steps here. But for the sake of you and your notes, that's exactly what I'm doing. Now I'm going to come up here and change this boundary. I'm going to change it to A because that's what I stored it in for. And I get 635.376. Therefore, okay, what were we asked to find? What is the maximum amount? So I want the amount. Therefore, the maximum amount is 635.376. Okay. Excuse me. Goodness. All right. How was this scored? Part A. Part A. 1 point for G prime, the value of G prime of 5, and 1 point for the interpretation with units. Points. Part B was also worth 2 points. 1 point was for the integral. 1 point was for the answer. Part C, also worth 2 points. 1 point was for what they said compares G of 5 to 100. And 1 point for conclusion. And there was a note that said you had to have earned the first point to earn the second point. So you couldn't just take a wild guess and say decreasing. You had to say why. Okay, so that means part D was worth 3 points. 1 point was for considers G of t minus 100 is 0. We did that right here to get our critical numbers. 1 point was for the answer. 1 point was for the justification. Okay. Next up, I'm going to take a look at the problem from 2015. The rate at which rainwater flows into, at which rainwater flows into a drain pipe is modeled by R. So this is our rate in. That will be my Y1. So to my calculator I go. And I'm going to carefully put in my rate in. Check it to make sure. Yes. Cubic feet per hour, 0 to 8 again. The pipe is partially blocked, allowing water to drain out the other end of the pipe at this rate. So this is our rate out. That's going to be my Y2. Carefully put that in. Excuse me. Okay, this one's a little bit difficult to type in. Okay, I think I got it in there right. Still for 0 to 8. And then they tell me that there are 30 cubic feet of water at time 0. That's our initial amount. Okie doke. Part A. How many cubic feet of water flow into? How much flows in from 0 to 8? That is the integral of the rate in. Integral of rate in. Math 9, 0 to 8, Y1. 76.570. At least 3 values after the decimal point, right? Okay. If I do it, did they want units? Nope. Okay. Part B. Is the amount increasing or decreasing at time 3? Is the amount increasing or decreasing at time 3 of water in the pipe? So I want to know, is R of 3 bigger or less than D of 3? Let's find out. I'm going to compare R of 3 and D of 3. So Y1 at 3, Y2 at 3. Which is bigger? D of 3 is bigger. So is the amount increasing or decreasing? It's draining more, so the amount is decreasing at time 3. All right, part C. At what time is the amount of water a minimum? Candidates test. Okay. Time, amount. Again, I'm going to call that A of t. And I'm going to say A of t is the initial amount. The initial amount was 30 cubic feet plus the integral 0 to t of the rate in minus the integral 0 to t of the rate out. Okay? So A prime is R of t minus D of t. The derivative of the amount is the rate in minus the rate out. Okay? And that is changing from, and I want the minimum, yeah? I want the minimum. So this time I want for it to go from negative to positive, for the rate to go from negative to positive. This is 0 and changes from negative to positive at, okay, so I want y1 minus y2, that's still stored in for my y3 from the previous problem, and then I have 0 in from the previous problem. I'm turning off y1 and off y2. I still have it set from 0 to 8. I have it negative 100 to 100. I don't know if I need negative 100 to 100. I have no idea what I need. I'm going to do that. Oh, I did not need negative 50 to 50. Let's change that window. Let's make it negative 5 to 5. How about that? There we go. Better. Okay. And it is changing from negative to positive. The rate is changing from negative to positive right here at time equals, gosh, that pink is so light, 3.2716. And I'm going to call that, I almost wrote an A there, I'm going to call it B, all right? Second quit, X store B. All right, now I have it stored in for B. And now once again, I just need my A values. The amount at time 0 they told me was 30. The amount at time 8. So again, I don't have to rewrite this because I already wrote it up here. So the amount at time 8 will be 30 plus the integral 0 to 8 of the rate in minus the integral 0 to 8 of the rate out. 48.5436. Okay, for B, I go up. I change these 8s to B's. To get that value. So 27.9645. So what was the minimum amount? This value. Yeah? Therefore, the minimum amount, oh, it didn't ask for the minimum amount. At what time? At what time is the amount a minimum? So the amount is a minimum at time B. Okay? So be careful what they're asking you for. Part D. Okay. The pipe can hold 50 cubic feet of water before overflowing. For time greater than 8, so beyond 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. Okay, so what is the amount of the water at this time W? Well, it's our starting amount, which was 30, plus integral 0 to W of the rate in, minus integral 0 to W of the rate out. And when that becomes 50, we're there. So this equation, when solved for W, would give us the time that happens. Okay, I think we're done. Let's take a look at how this one was scored. Okay, for part A, For part A, that quick problem there. For part A, 1 point for the integral, 1 point for the answer. 2 points. For part B, 1 point for what they said considers R of 3 and D of 3, and 1 point for your answer with reason. Two points for that one. Okay, part C. Part C was worth 3 points. 1 point for considers R of t minus D of t equals 0. That was for our critical numbers. 1 point for the answer. 1 point for the entire justification. Excuse me. Part D, 2 points. 1 point for the integral, or integrals if we used two. We used two integrals. We could have combined these since the boundaries were the same. We could have combined those to make it one integral. 1 point for the equation. Does your equation work? Do you have an equation? You'd be surprised at how many times when the directions say write an equation, the student does not write an equation. So anyway, and that's it for rate in, rate out. Another common type of problem.